Exponential functions are useful because there are several phenomena that can be modeled by exponential functions, such as population growth or radioactive decay. Here are some tips for thinking about exponential functions that will help you in understanding word problems and how to work with them. So if we have our regular exponential function in this general term, first of all, f of x is the final amount. Because it is the answer that comes out upon putting in the input. Some other components is that a is the initial amount, for b being 1 plus the growth rate is going to be growth, so it's going to be increasing. And for b equals 1 minus the decay rate, this is going to be decay, so decreasing. And then x is the number of growth or decay periods. Those were some explanations of what parts of the functions mean. Now, here are some tips on interpreting word problems that are useful for modeling these exponential relations. When working with a growth rate as a percent, the base is equal to adding the rate as a decimal. I'll write that down, and we can see an example of where that happens. So when we're doing growth rate, the base is equal to adding the rate, the growth rate, as a decimal. So if we are told growth rate of 8% is going to be multiplying by 1.08 repeatedly. This is going to be equal to a growth rate of 8%, and that is because we have our initial, so if we were to not grow at all, then we would be just multiplying by 1 each time, meaning that the a, which is the initial amount, would be staying the same. But we do have a growth rate, and it's 8%. 8% can be represented as a decimal as 0.08. And when we are multiplying as an exponential function by the base, we have to do 1 plus this percent, because then you're actually going to get that 8% or 0.08 increase. Now, when we're working with decay rate, you have the base being equal to subtracting the rate as a decimal. So for example, if we have a decay rate of 8%, then we are multiplying repeatedly by 0.92 because it's 1 minus 0.08, which is 0.92. If it's less than 1, it's going to decrease. That's the point. And in the last tip, watch that the units for the growth or decay rate is the same as for the number of growth or decay periods.